Consider it done. And now
All right,
you
you're on. I'm muting.
no need to mute yourself. Here we go. Now I want to share. You guys see which screen?
Both.
How about this screen?
We see next slide. No, now we see a full slide. Got it.
Awesome. All right, guys. So today, what I wanted to share with you all is 2R and a new 2R controller. My name is Noah Cruz. I'm a water conservation manager for Northern California and the Pacific Northwest, working with Mark Hall. He's our area specification manager for Northern California. And click on this. All right, so today's meeting, day 2, we're talking about what, as far as the what goes for the controllers. One big detail that I've noticed is we're having a pretty consistent issue with contractors not knowing how to properly ground controllers. We'll touch base on that as well today. As far as controller options, we have TM2s all the way to IVM Pro, any configuration we can accommodate for programs, stations, flow, weather, etc. Biggest differences. Now the LXD controller has 4 independent 2-wire paths from that ESP LXD M50 base module. This controller can accommodate up to 8 simul stations with Rainbird commercial valves. This has to do with the commercial solenoids. Biggest difference now, going from this platform over to the new IVM controller. IVM stands for Integrated Valve Module. This controller works with a decoder solenoid combo that takes the place of a decoder and a solenoid. Best of all, this base module in this controller has 4 independent 2-wire paths. So if, say, there were 4 different 2-wire paths that ran, say, north, south, east, and west, let's say you had a short on the east side, north, west, and south would still function properly until the short was cleared on the east side. So these are 4 independent 2-wire paths. Huge benefit there. Another big benefit to this controller is simply that it works with latching solenoids. The IVM Sol is an IVM solenoid combo in 1 unit. That's an AC pulse latching decoder solenoid combination. It also works with competitor valves with any DC latching solenoid. The beauty to this topic is that this controller can accommodate up to 16 simul stations, 10 master valves, 10 flow sensors, 8 weather sensors, and there's never a difference in the milliamp load on the controller. These controllers manage both water and their milliamp load of electricity. The best part about this controller is that there's no difference in a milliamp load if a station is on or not. Thus, we can accommodate up to 16 simul stations plus 10 master valves. That's potentially 26 solenoids that are open simultaneously. Critical for contractors to know is that every controller needs a rain sensor, period. I don't know of any controller in the market that can accommodate a rain shutoff based on any internet connection. Every controller needs a rain sensor. They're cost effective. Best of all is we have the new 4G IQ cartridge coming. It's almost released. The beauty of this system is that this gives end users the full capacity of weather-based adjustments, flow, alarm, monitoring, reports, and there's no additional cost whatsoever. This IQ cartridge does make all of our LX controllers EPA WaterSense certified. The installation details have not changed for the LXD and IVM controller. Wire gauge size stays the same, wire distance stays the same. This also includes our looped configurations. Biggest differences going on now. These are the field decoders, the FD field decoders, from 1 station up to 6 stations per decoder. This is our G4 solenoid. It's critical to note that the reason why the LXD controller can accommodate up to 8 simul stations has to do with that G4 solenoid. That solenoid was designed and engineered to function from 8 volts up to 26.5 volts. Our decoders hold 8.1 volts to keep solenoids open. I just need to share that I've never seen any field decoder from any manufacturer ever hold out more than 14 volts to keep a solenoid open. So for the long-term success of a site, it's critical to also manage the electrical side of an irrigation controller. This is a sensor decoder that accommodates flow sensing, even a rain sensor, even an anemometer for wind. So this controller has that capacity. These are the three valves that we sell the most: PEBs, PGAs, and the EFBs that have our G4 commercial solenoid. Moving on to now our IVM Sol for the IVM controller. That is an IVM Sol, stands for Integrated Valve Module Solenoid. That's a solenoid AC latching, AC, and decoder built in one. If a customer, say, has a Buckner, Superior, or Griswold normally open master valve, we have what's an IVM out. This functions with a 2-wire connection, which will also accommodate any DC latching solenoid. This also includes pump start relays. If there is a pump start relay needed for any job, and the only difference with an IVM controller is that that pump start relay needs a DC latching relay. That's it. This is an IVM Sen, same as a SD green decoder on the left. The IVM Sen stands for sensor, can also accommodate wind, rain, flow, up to 10 flow sensors, and up to 8 weather sensors on the IVM Pro controller. Most critical that I see very consistently are issues in the field with line surge protection. The yellow LSP-1 is for the LXD. The LSP-01 on the right is for the IVM controller. Grounding 2-wire controllers is critical, and most contractors do not know about the sphere of influence regarding grounding. Thus, it's fairly critical that landscape plans do accommodate drawing where grounding rods go, what they are. What should be specified? That depends upon the exact site and the ohms resistance between the controller and a grounding point, 2-wire path and a grounding point. Basically, the sphere of influence of a rod length were, say, 8 feet long, it must be 9 feet away from the controller, as it has a sphere of influence for any potential lightning strike to have a discharge to earth grounded more so than a 2-wire controller and or this 2-wire cable through 6-gauge bare copper wire. People ask me all the time, can I run 2-wire to it? I guess you could, but it's actually ideal to run 6-gauge bare solid copper wire. Contractors need to see this in the field. They need to see where exactly they should install these grounding points. For example, I have a customer that I worked with even yesterday here in Elk Grove, California. He had specified to use a 10-foot grounding copper pole, 5/8 by 10 feet. That was excellent. Luckily, in Elk Grove, it's been raining, so the soils are wet enough to install. Problem: the contractor installed the 10-foot pole horizontally, not vertically, which changes the complete ohms grounding of any grounding point. So if anybody needs more questions answered regarding grounding, I would love to be a resource to help out with the requirements of a certified grounding point, passing a test. And if I could help out in any way, please just let me know. Any questions? What are your thoughts?
Hey, Noe, on the slide before this one, when you're talking about the oh, I'm sorry, before this, there the two decoder sensors
Yes.
right there, the one for the IVM out and the IVM sensor.
Yes, sir.
Okay, I think it's the IVM sensor you said could accommodate what 10 flow sensors and what 8
Weather.
weather sensors.
Yes.
Is that collective? So it could be like a total of 18?
Yes.
Or, oh, it could be. Okay.
Yes. So flow sensing is a different programming aspect of the controller than weather-based adjustments. So we even have that sensor can be programmed as custom. So that's basically what we do for wind. We put in a custom feature, the pulse transmitter, so that if the wind were, say, to exceed 15 miles per hour, it'll simply pause irrigation, not stop it. Rain would stop irrigation. Wind would simply pause it. So when wind, say, were to go down below 15 miles per hour, irrigation would commence as where it left off. So flow and weather are two different programming features to the IVM controller.
Okay. Thanks.
Another thing that came up from a specifier here was they currently specify LXDs.
Okay.
They're new as far as they don't know anything about the IVM besides what you've just gone over.
Okay.
Why would they continue to specify LXD if IVM is a better option?
Is it just Rainbird employees on this call?
No, no.
Okay.
There's some that aren't seen.
Okay, no worries. So
No, I'm just saying that's no, and it's fine either way. But they're in the habit of specifying LXD.
yes.
Yeah, but if the IVM, if it's more expensive, that could be one reason. But it seems like there's a lot of features with IVM that LXD.
To start, the IVM controller is a far more powerful controller, period. The LXD controller is still a fantastic controller. We're honestly still going to make it for replacement parts or future maintenance accounts, things of that nature. However, the IVM controller is far more powerful in its features, its programs, its capacity for sensing and water management, not being limited to having to manage milliamps based on a competitor's solenoid. Because everything is latching, this controller has far more abilities than the LXD. It's far faster to install, half the splices. That's half the failure rate to most 2-wire job sites. So the reality is the IVM is by far a better controller, bar none. LXD is still a fantastic controller, but if I were doing a new job, I would definitely specify the IVM. And the beauty is, if any customer were to say transitioning from IVM up to 60 stations and wanted to go up to 150, the only difference between the two controllers is just the panel. There's no modules to add. It's pretty simple to swap. It would take maybe 5 minutes to interchange. So the honest answer is the IVM is definitely a superior 2-wire controller. Not to mention the fact that 2-wire electrical management is far easier for the end user because there's no increase or decrease in the milliamp load based on any sensors or valves or pump start relays being activated. Everything's latching, thus it makes it very simple to troubleshoot.
Okay, great. What about the percentage of cost? Not an exact price, but usually if it's within marginal, if it's 10% more or 15, no big deal. But are we talking 20, 30% more for this or no? For the IVM?
I don't like talking numbers, but I'll be honest. The IVM controller costs less than the LXD. The IVM Pro costs more than the LXD. So you have a good, better, best as far as cost goes. The IVM actually costs, probably 15% less than the LXD. IVM Pro costs about 20% more than the LXD.
Okay, great. That's perfect. And the other one that I have is when you look at the integrated valve module and compare, does our competition, anybody have that option? Does any other manufacturer carry that?
No. So Rainbird is the only commercial such control manufacturer to this level that makes all products, including valves, rotors, sprays. Thus, we are able to accommodate our decoder solenoid in one unit, and nobody else can really do that.
Okay, that's huge because that pretty much separates us 100% from them. So that's all I have.
Yeah. So Noe, you said when Mark asked you why a specifier or a contractor would pick the IVM over the LXD, right? I heard a lot of stuff. Could you break it down into just 3 bullet points on why they should go with the IVM over the LXD? Let's say for like Odyssey right now.
So what's the difference? The IVM controller is far easier to install, especially with Rainbird valves. The IVM controller has more features within the programming for the controller itself. And the IVM controller is essentially the platform for the future of our LX controllers.
Okay, great, perfect. So what makes it easier to install?
The easiest detail about installation is the fact that the IVM soles only have 2 wires, not 4. So they are more efficient in their time to install. Not to mention the fact that the IVM sole wires, yes, they're fairly malleable. However, when installing on rigid 2-wire, they install nicely in the 2-wire splices. The LXD controllers feel the most when they get moisture on the decoder output side, where the decoder wires meet with the cylinder wires. They're not stiff enough to properly seat in splices. Whereas the IVM soles, there's only 2 wires, thus they connect to the rigid 2-wire copper, and it makes for an easier, cleaner installation for the contractor, thus far less troubleshooting in the future. And for a landscape architect, there's much more features to the programming that could accommodate up to 40 programs, not just 4.
Okay, perfect, thanks.
Any other questions?
The 4G cartridge,
Yes.
everyone's asking about it. Do we have, like, is it gonna be 2020? This thing's coming out,
Yes.
like
That's a
summer
great question.
2020?
So what we've seen is 3G is not going away until February of 2022, from my understanding. What is changing though is AT&T has changed their towers for communication. 4G has excellent signal strength. However, we've noticed that signal quality has been an issue. So our communication engineers are trying to troubleshoot signal quality. So there's too many 4G devices in an area, you end up with a lot of background noise, and that's been affecting communication. That's why it's not released yet. We want to release a product that is bulletproof. So it's getting there with engineering the correct antennas. So honestly, completing all engineering design, we're looking to be done with that in about a month. I honestly see the 4G cartridges being released before summer.
Okay.
I'm not going to give a date, but I see them coming out before summer.
Okay, so I'm gonna say June 21st, first day of summer.
Well, we're looking for June 15th, but I don't want to say that.
So June 15th per Noe.
Don't quote me, please.
No, I appreciate it. Thank you.
No, we just got a couple of minutes, so if you could wrap it up. I don't know if anybody else has any other questions. I don't have anything on my end at this time.
The biggest detail to cover is I would love to see more specification done describing to contractors in the field how to ground a controller. Besides see manufacturers' recommendations, I went to a job site yesterday where this contractor was adamant in installing per plan, but the plan said see manufacturer recs recommendations, and it was a painful conversation. I think that it would be helpful for all of us to have grounding specified properly. Any questions?
Do you have that? Sorry. Do you have that detail? Not that I know we have our standard details in AutoCAD, DWG format, PDF, all that. Now, the one that you're showing us now, do we have that?
Yes, I have full ASIC electric coding for electrical grounding. That has nothing to do with Rainbird. It has to do with the electric companies, and I could definitely share that with anybody that would request it.
Okay, cool. It'd be nice to get that, on our website, possibly.
It is. It is.
It is? Okay,
You want
awesome.
to send a link? I'll send you a link that you can share. It is on our website.
Awesome. Thank you, sir.
Thank you.
Appreciate your time. Awesome.
Thank you, guys.
All right. We will stop the share, I guess. Can you do that from your end, Noe?
Yes, sir.
Perfect.
I'm going to stop the